Sound waves. Sound, it is composed of waves of compression and rarefaction in which the human ear is sensitive. Compressions, the close together part of the wave. Rarefactions, the spread out parts of a wave. Okay? Ito po yung compression and ito po yung rarefaction. Okay? In which media does sound travel fastest? Okay? Is it in solid, liquid, or gas molecules? Sound travels better through high density materials. Okay? And then the closer together, or the closer the molecules are together, the faster they can collide and transfer energy. In short, in solid, the sound waves travels fastest than the other media. Speed of the sounds. The sound travels the fastest in solid because the particles are close together. The speed of sound in solid is 5,000 meter per second. Okay. The speed of the sound, whereas in liquid, it is 1,500 meter per second in a medium speed, while in the slow speed, we have 330 meter per second. Speed of the sound depends on one type of medium. Travels better through liquids and solids and gas. And speed of the sound depends on that can't travel through vacuum. And then speed of the sound depends on the temperature of medium, travels faster at higher temperature. The speed of the sound depends on density, that sounds move well through dense materials. Elasticity, number 4, is the sound waves move fast through elastic materials. Speed sounds in a Doppler effect. Doppler effect is a change in wave frequency causing by a moving wave source. Okay, moving toward a pitch sounds higher. Moving away from you, pitch sounds lower. Example of this is ambulance, fire truck, and the train. Sonar. Okay, an instrument that uses reflected sound waves to find underwater objects. Okay? Humans use sonar to locate or map objects or location. Normally, ginagamit po ito ng mga barko para mahanap ang mga location or object na meron sa ilalim ng dagat. And then, animals also use sonar or echolocation to find their prey. These sounds have such a high pitch or frequency that the human ear cannot hear. Best example is the bats and the mammals, which is the whale. Why can't sound travel through a vacuum? Because sound cannot travel through a vacuum, and a vacuum is an area without any air, like space. Okay? So, sound cannot travel through space because there is no matter for the vibrations to work in. Human hearing. The sound waves enter to the outer ear, okay, then travels to the ear canal, vibrates it to the eardrum, and the eardrum will signal or amplified by the bones. Okay? Once it is amplified, pupunta po siya sa nerve at dediretso sa ating utak o converted into nerve impulses in cochlea, and then dun po natin maririnig kung merong sound wave po yung isang bagay. Ibig sabihin from the nerve, the auditory nerve, direct to our brain. Take note, yung five senses, Yun po ay mayroong nerve na naka-attach sa ating utak. Oscilloscope is an instrument which allows you to see the waves produced by sound. Okay, the old type of CRO is a cathode ray oscilloscope. A newer type of oscilloscope is the digital oscilloscope. So normally this type of device is seen in the hospital. Let's move now to the properties of sound. The pitch, or we have pitch, is the highness or lowness of a sound. Okay, in a pitch there is a frequency, which is the number of sound waves that passes through a point in a certain amount of time, such as 1 second. So the frequency class is the greater the frequency, the higher the pitch. So in order for you to measure the frequency of the pitch, we need to use the units hertz. This is how it looks like, the pitch. Okay, if you have, or if you've seen like this one, okay, low pitch, low frequency, and longer wavelength. Palatandaan, if the wavelength is quite longer, ibig sabihin very low ang pitch, very low ang frequency. But if the frequency or the wavelength is shorter, which means to say the frequency is high pitch and it has also high frequency. Tandaan po natin yan. Ultrasound, sound waves with frequency above the normal range of hearing, okay, of human. Sounds in the range from 20 to 100 kilohertz, okay? And an infrasound, sounds with frequency below normal human range of hearing. Sounds in the 20 to 200 hertz range. Take note, the normal hearing of a human is in between 20, 21, 22, 23, 14, 5, or below 16, 17, 18, 19. So in that range, we can still hear sounds. Okay, beyond that or above that, mahirap na po ma-detect yung sound wave na napuproduce ng environment o ng ibang bagay. Okay, infrasounds, as I said a while ago, the infrasound ay hindi po maririnig ng tao, but the pitch of the wave is too slow pag infrasound, just below 20 hertz. So below 20 hertz cannot be heard by humans. However, animals such as whales, giraffes, and even rhinos can hear infrasound, using it to communicate. Take note, and animals are very familiar with this about infrasonic sound or infrasound. Now let's move now to this diagram. Okay, this is the human hearing range. Okay, this is the infrasound below, and this one is the ultrasound. Okay, take note, in ultrasound we can use, or this one is used in the medical instrument, and only the bats, dolphin, or other form of fishes can hear the ultrasonic sound in the environment. Okay, and again, there are also animals that can hear the infrasonic sound or below the human range of, below the hearing human range of the human. Okay, and then this is an example of ultrasounds or images or image produced by the ultrasound. Another properties of sound is loudness or intensity, which means descriptions are how high or low the sound seems to a person. So loudness is to determine mainly by the amplitude of the sound wave. Okay, tandaan po natin yan ha. Ang the loudness and intensity can be determined through amplitude. Okay, decibel used, or it's a unit used to measure sound's intensity or the loudness. This is an example or the range of the soundness level or the decibels that can produce. Okay, 40 to 50 decibels class, this is the normal loud. Ibig sabihin, ito lang po yung medyo okay sa ating pandinig, yung ingay. But beyond that, or above that, 90 to 100 decibels, if we too much hear those loud sounds, after that, you will have, baka mabingi po tayo, hindi na tayo makakarinig ng maayos. Even in rock concert, okay, we have 115 to 120. And in jet engine, you have 120 to 170, and you will receive the pain or hearing damage, or the pain or the progressive of the pain. Ibig sabihin, if you too much hearing about the loud, the rock, and the jet engine, makakaranas pa tayo ng hearing damage. So, if the loudness is in between 40 to 50, mas pwede pa or na-absorb pa po natin yung ganong klaseng uri ng sound o loudness or intensity ng isang bagay. Number 3, the timbre. Timbre is a tone color or a tone quality used to distinguish between two different sounds that have the same pitch and loudness. So timbre helps to identify what produced the sound. Okay, there are two different waveforms of a timbre. First, we have pure tone, or the simplest waveform. It has a soft, pleasant tone and quality and sinusoidal. Unlike complex tone, it's nearly sinusoidal. Okay. Now, this is how it looks like, or an example of timbre. We have the violin, the voice, the flute, and the tuning fork. As you can see, class, the flute, the voice, and the violin are considered as the complex, okay? While the tuning fork is considered as the pure tone. Take note, para malaman po natin yung timbre ng isang voice o isang sound, kailangan po nating malaman yung itsura ng frequency ng isang sound waves. Kasi doon po natin makikita. Okay? Kinds of sound waves. We have audible sounds. So human can hear. Okay? Human can hear. Human can hear from 20 to 200,000 hertz. The ultrasonic sound waves cannot be detected by human ear, as I said, but some animals do. Dogs can detect 50,000 hertz, and bats can hear up to 100,000 hertz, uses in ultrasound. While in infrasound or infrasonic waves, the sound below 220 hertz, the source of these is the vibrating of the heavy machines, the earthquakes, the thunder, and the volcanoes. So it cannot be heard by human ear, but can cause damage. Okay, the range of hearing, singing, and the quality of notes. So we have smooth. This is how it looks. It looks like the wavelengths of the smooth, the harsh, this one, and the very harsh. Okay, this one is the pure note. Okay, observe. This one is the allowed pitch note, and this one is allowed but low pitch note. This one is very noisy. Okay, makikita po natin yan. And this one is a soft and high pitch note. And this one is a soft and a low pitch note. Okay. Now, a rare fraction of sound class change in direction as the wave moves from a medium to another, so it bends or refracts as they move through air. So sound waves refract, refraction of sound waves, ibig sabihin nagre-refract, okay, nagbe-bends, okay? Tandaan po natin yan, ha? From there, ito yung source, ito yung listener. Pag nagsasalita, it goes somewhere else. Okay? It goes somewhere else. Yung sound waves. Okay? While in reflection of sound, echo is reflected sounds, and it is what you hear shortly after the original. Normally, you can notice this if you are shouting. Ibig sabihin, nag-shout kayo doon sa bundok. Okay, nag-echo, o kaya sa cave, nag-echo. So those are the reflection of the sound, or example of echo. And then diffraction of sound. Sound waves bend or diffract around corners and barriers like doors and walls. And this is how it looks like the interference, the result of two or more sound waves overlapping. Ibig sabihin, lahat ng sound waves na naririnig natin ay nag-overlap. For example, ito yung sound waves ng TV, ito yung sound waves ng radio, ito yung sound waves ng nanay mo. So, if these three overlap, so ang tawag po natin ay interference. Okay, resonance, the inducing a vibration of a natural rate by a vibrating source having the same frequency. And the last is we have noise, okay, unwanted sound and subtle pollutant which can threaten the health or well-being of an individual.